In the last video file, I showed you how to reset the calculator. In this file, I'll just demonstrate how to use your BA2 Plus to perform some basic calculations in time value of money. Let's start with the first slide here. If we want to find the future value of $100 in 20 years, if the interest rate is 5%, to calculate the future value, simply enter 100 as present value, 5% interest rate, so only 5, not 5%, as IY, 20 as N, and we can leave 0 payments and compute for the future value, which turns out to be 265. And of course, in this case, if we simply need to change N from 20 to 40, then 40 N. If all the other things are the same, we can leave them as what they were and compute for the future value. Turns out to be 704. And if we want to start a new calculation in time value of money, I would always recommend you to try second clear everything, clear all the previous record before you start a new calculation. So the next calculation is to solve for the present value when you have 100, future value, 2 years, 5% interest rate, again, no other cash flows or payment, compute for the present value. And when you input, it doesn't matter which one you input first. You can try 2 as N first, or you can try 100 as future value first. It doesn't matter, as long as you input all these 3 or 4 variables and then compute for the present value in this case. Let's move on. If we want to solve for the interest rate, remember, between the present value and the future value, one has to be negative. So negative present value, and we have 475 future value, and this is done in 3 years, and we're gonna compute for the IY. Turns out to be 10.72%. And if we want to solve for the number of years, very similar. Remember, between the present value and future value, one has to be negative. You can actually try, let's say, positive present value, and then don't forget future value will then be negative. And this is interest rate of 7%, and we compute for N, turns out to be 527. So remember, if you use negative present value, then you use positive future value. And what I showed you, I used positive present value and negative future value. So between these two, one negative, one positive. Okay, so far this is single cash flow. And then we want to deal with multiple cash flows, and we start with annuities, which has even amount of cash flows all the time. For ordinary annuity, when we try to calculate the future value, this is a 3-year annuity, each payment being $100. So, well, you may want to second clear everything first, and 100 payment, 3 years, interest rate is 10%. You want to put a 0 as PV because in addition to the 3 payments, there's nothing else at the beginning. So 0 PV and compute future value 331. And well, guess what we have to do if we want to solve for the present value? We go 0 future value, and you can repeat 3N, 10%, IY, 100 payment, compute for the present value. What if we have annuity due? Remember, the difference between annuity due and ordinary annuity is that for the annuity due, each payment is made at the beginning of each period. So what we can do is to switch to the beginning mode. To do that, you want to go second payment. Above the payment, you see the BGN, which stands for beginning. At this point, the calculator by default is set at the end mode, and you want to reset it. So second set, you see it switched to beginning mode, and you have a little reminder here at the upper right corner of your screen. So now if you want to get out of this, see the reminder? This is to remind you that now you are at the beginning mode. 3 years, 10%, $100 payment, 0 PV, compute for present value, future value, I'm sorry. So notice the readout here is 364, and under the end mode, you got the readout of 331. So your annuity due has a higher future value, and this is actually 10% higher. Or say 364 is 331 multiplied by 1 plus the 10%. Okay, to calculate the present value of this annuity, still under the beginning mode for this annuity due, 100 payment, 0 future value, 3 years, 10% interest rate, compute for present value. Okay, so far this one row of 5 buttons, you figure out what do you have to compute and what do you have to input. Okay, now if you now want to go back to the end mode, just do whatever you did to go to this beginning mode. So second payment, or say second begin, and under the beginning mode, second set, now we are back to the end mode. Okay, so now we are looking at uneven cash flows. This is a series or streams of uneven cash flows. Unlike annuities, which have even or same amount of cash flow all the time, the uneven cash flows deal with, well, uneven amount of cash flows. And what we have to do is to use the cash flow registries in your calculator. So we start with CFO. Once you press the CF button, you will see CFO. If you look at the timeline, we have nothing at the very beginning on time 0, so CFO, leave it as 0, and use the down arrow button to go down to start inputting your cash flows. Your first cash flow is $100, so 100, enter. Make sure you press the enter button, so CO1 equals to 100. You press the down arrow button again, it asks you for F of 1, which is the frequency of this $100. How many do we have as $100? Only 1, so you can just leave it as 1. And then we have next cash flow, $300, and after you input $300, go down and it asks you, okay, how many $300 do you have? Well, we do have 2 right next to each other, so we can actually go 2 and enter. Every time you, in this cash flow registry, every time you input a number, don't forget to press the enter button. And what is the next cash flow? After 2 of the 300, the next one is 50 negative. Don't forget, enter. Go down. That's only 1, so leave it as 1. Now we finished inputting all the cash flows. We just go press the NPV button. So NPV button is right next to the CF. And I is interest rate 10%, enter. And now you want to go down and the screen shows NPV. We will press the compute button once more and we will get the final result for the NPV of this uneven stream of cash flows. Okay, so this is to calculate NPV, which is the present value, net present value of all these cash flows, uneven amount. Then next, I'll show you how to use the built-in function to calculate the effective annual rate. If you don't want to go through the long formula in your book or notes about effective annual rate, here's the shortcut. Suppose we have 10% nominal rate, monthly compounding, or say 12 times a year. What we can do is second I count, interest conversion. Nominal is 10%, so 10, enter. And you can go down, and this is showing you the effective rate. At this point, just leave it and go down one more time. Compounding times in a year, we have 12 times in a year for monthly compounding. Okay, enter. And now we go back to the EFF. Don't forget compute. So the effective annual interest rate is 10.47% when the nominal or quoted interest rate is 10%, but you do monthly compounding. What if we actually want to do daily compounding? 365 times a year, enter, go back to EFF, compute 10.52%. Okay. Last set of calculation is about amortization, the loan amortizations. What we want to do first is to calculate the amount of the loan payment every time. In this example, let's go back to the time value of money. So we want a second quote and second clear time value of money. So we clear all the previous work and we start inputting $150,000, the principal of the loan as the present value, 3 years, 10% interest rate 0. FV compute payment 60,317. To understand the structure of this amortization, we want to go second amort, and for example, if we leave P1 as 2 and P2 as 2, we can go down and we will see the BAL, which is the remaining balance. It will show us $54,800, which is the remaining balance after 2 payments, or say after 2 years in this case. How much do you still own after 2 years? We can also try go down one more time. See the interest, 10,468. That means within the second payment, which is the payment made at the second year, $60,300. Out of that, you pay 10,468 as interest payment. Now, if we go back, change P1 to 1 and leave P2 as 2, notice the remaining balance doesn't change, but interest changed. So this is a total interest payment from the first payment to the second payment, total of 2 payments. Out of the 2 payments, total $25,000 are paid as interest payments. So these are all the essential calculations for time value of money introduced in this class.